Hello guys, welcome to my YouTube channel. Today we are here to solve Leetcode problem of the day, and today is 27th November 2024, and the today's problem is shortest distance after road addition query 1. So from the heading or title you can say that there is something you need to find the shortest distance, and instead of finding the shorter distance, you have to add some extra road, and there might be some query. So this is the title, and this title is saying that you have to find the shortest distance, and there will be the road addition, and there will be some queries. Okay, so you will see that this is the now let's read. Before reading the problem statement, you have to just guess that what could be the problem without reading the all statements. So you have to see this. Okay, so you will see that something like there is the n cities from 0 to n minus 1. Initially they are unidirectional. Okay, and initially you have to take care of it. Initially road I is connected with I plus 1, and that is unidirectional from A to B, not B to A. There is only directed road that will be from A to B. Okay, this is the there will be the query, and you have to find the shortest path. Okay, so at the beginning you can see that this is okay, all are connected. Now 2 to 4, it says that 2 to 4 is getting connected. So without reading the whole state problem statement, you can see that you have to just find out something like from here to here you have to reach. I mean, you have to connect the road, this extra road you have to connect, and now you have to find the shortest. And how you will find the shortest? So now you see what is the shortest. Answer I. You can see that answer I from the shortest between 0 and n minus 1. Sorry, 0 and n minus 1 from processing the first I plus 1 query. Okay, basically now you can think that what is the actual problem is. Just you have given the query, you have to connect this road, and you have to find minimum distance from 0 to n minus 1, and there will be n nodes. Initially they will be connected from G, I mean I is connected to I plus 1. So this is all about the problem. Now you can read the problem statement and you have clarify. Now you can see the constant is there, like 500 is there, so maybe n square, n cube, no, n square will be perfect. Okay, then this is the 5 and query. No, n square is not perfect, but multiplication of these two would be the perfect, that you can take the order of n complexity, time complexity for the nodes, number of nodes, and linear time complexity for this. So if the solution will goes in multiplication of these two, let's suppose it is n, and now length is query length is m, so you can go till m into n. There will be no problem in time complexity. So this is all about the problem. If you will now read the whole statement, you are given n and 2D integer array query. So as I have already told you that unidirectional, and I is connected with I plus 1, and there is 0 to n minus 1, total n node, and numbered from 0 to n minus 1. And query I represent that unidirectional addition of road from city ui to vi. You need to find the sorted distance between 0 to n minus 1. You have to return an array that will be equal to the length of query, and in each query you have to find out what is the shortest distance between 0 to n minus 1 after addition of this road in already given path. So this is all about the problem. Let's now think that how what will be our intuition. So let's start now. If this is the input, so if this is the input, how we can approach that? You have to find the shortest. So for the shortest path, what came in our mind is BFS. We should think about the BFS. That is the optimum. So if there is no road, let's suppose that it is also not connected. So basically at the beginning it will be from 0 to 1, 1 to 2, and similarly from 3 to 4. So if you will add this, so this will be added. Now what will be the shortest distance between 2 to 4? So this node you can skip now from 0 to 1, 1 to 2, and now 4. So what is the distance? Is 1 and 2, and this one is 3. That's why the answer is 3. Now again, if you will add 0 to 2, okay, from 0 to 2 you have to add, okay, I have added one more path from 0 to 2, and now what is the shortest path? This one and this one will be the shortest one from 0 to 4. So that's why the answer is 2. And this also will have been executed, this also have been executed. Now execute from 0 to 4. So if you add a path that is directly from 0 to 4, the answer will be only this path. We will neglect all these paths because it will give longest path. So we will assume this path, so that's why the answer is 1. So this we have also executed this node. So this is basically the classical problem of breadth first search, BFS. I mean, this is the classical problem of BFS. So if you don't know how to traverse the BFS and how to implement the BFS and how to insert the data in BF in queue and how to extract, you should first learn that how BFS works. So if you know very well, you are ready to solve this problem. This is very easy problem, but it is easy if you already know BFS. So let's start the coding now. So what we will do, we will just implement the BFS. First you have to make the adjacency list. So let's suppose if m is registered length, so I will make there is one more dependency. You have to have the you should have the idea that how we implement the tree using the edges that are given to us. So let's go adjacency, new array list. Okay, the size will be n. So now I will be slicing each node with edges of I equal to new, and you have to, as it has given here that initially I will be connected with I plus 1. So here I am also adding if I given less than and minus 1, because that the last node will not connected to anyone at the beginning. So that's why I am just putting this conditional statement that whenever when I should add I plus 1, sorry. Okay, so we have created the tree. हाँ खोलो. So you can see here that we have implemented the adjacency list. Now what next? You have to first add. So for int I equal to m colon I equal, sorry, so you have also to the answer array of size m, and at the end you have to return. Okay, now you have to add, so a digit of adjacency of queries of I comma 0 I no 1, because it is unidirectional, as it is also given that it is unidirectional from I, from UI to VI. That's why we are just adding these edge. We are not adding the reverse edge because it is unidirectional. So you have to now have to find, you have to have a function which can return the sorted distance between 0 to n after the addition of this edge in the existing in the existing in the existing graph, so now let's suppose that it is given, then answer of I, let's suppose the function is bfs, so this will be the function which will return the minimum sorted distance from 0 to n minus 1. So now let's implement it. So you have to have the array list adjacency, and you have to have n. I guess it is enough. So if there will be more requirement, then make it n equal to boolean of size. What will be the size of, you have to check that either it is already been visited or not, because I will let you know. Okay, then you have to implement the VFS. You have to have the, oh, okay. Now you have to add the queue, because we will start from 0 and go till end. So this have been added. Now you have to find until queue is not empty, so not. Okay, now you have to check what is the size of queue, or the size you have to hide. You have to pop the element. Let's suppose it is the current element. So for the current you have to pop the element if you dot. Okay, now you have to mark as visited. So visited, you have to check that either, you have to also make a variable like int count equal to 0 if you know you have been there to the destination. You have to return the moment. So if current equal to n minus 1, in this case you have to return the count. else you have to check that if where you have to make the for loop. I guess in e current you have to check if not visited, I mean say not visited a, if not visited you have to add in the queue. Oh, offer e, okay, and whenever it will end you have to increase the count, because you have to just find the label in which label it is available. I guess it has been completed. If not empty, you have to find the size, and for the this size you have to pop the element and you have to check the market visited, and if you have already been there to the destination you have to return the count. If not there, so you will have to iterate all the element that is available in the current, so you will have to add it. So I think that is completed. Now let's try to run the code. Because it is DFS, you have to give the adjacency and then you have to provide it. So you can see that these test cases have been passed, that is available here. So let's try to submit it now. So you can see that our code M is submitted and successfully submitted. You can see that our code have taken 313 millisecond and beats 21.7% of the people who have been submitted in Java. And let's try to analyze the time complexity. As I have already told you at the beginning that the time complexity would be m into n. So let's try to see it here. Oh no, I don't know. But the time complexity is m into n. You can see that this will, in the worst case, it will take order of n, and you, because you are iterating each query, so for this one the for this one the time complexity would be m, so the overall time complexity is m into n. So memory constant you can also see it here. So this is all about the problem, today's problem. If you have any query or suggestion, you can ping me below in the comment box. Please make sure to subscribe my channel. Please like and comment your suggestion or query below in the comment box. Please also make sure to share with your friends who is interested in CP and DSC. Thank you for the today.